Hi there, this is just another video of me solving randomly code problem. So implement a first in first out queue using only two stacks. The implemented queue should support all normal queue functions like push, pop, empty, and pick. So they given us a bunch of function here, and we can only use the standard operation on the stack, which is like push and pop in the end. So we can use the array to uh implement the stack. So if we have a stack like this, then we can push into the stack, which is O of 1, right? Push is O of 1. Um, and then when we check for if the queue is empty, right, it's also in constant time. So empty is also O of 1. And then push is O of 1. Pick is also O of 1. We just have to index into the first element, right? But pop, if we pop, we have to pop on the left side, right? Because this is a queue, first in, first out, right? It is our queue, 1, 2, 3, and 4, right? So this is the head of the queue, first in, first out. So because one is pushed inside into the array first, we need to remove one first, right? But if we remove one, we need to reassign all of the indices, right? So that is O of n. So pop is O of n, right? So every operation looks good except the pop. So how do we reduce the runtime of the pop into an average runtime of like constant of 1? So we can do that by using two stack. So let's say we have the stack 1, and we have 4 elements, 1, 2, 3, and 4, right? And stack 2 is empty, right? So whenever we want to push something to the stack, we just push it to stack 1, right? But if we want to pop it off the stack, which is the one here, right? The number one here that we're currently looking at. So we can move all of the elements from the first stack to the second stack. So stack 2 dot push stack 1 pop, right? Because by doing so, we can reverse the order of the element, right? Now the number one here. So now, first of all, now stack 1 is empty, right? Because we just transfer all the element into stack 2 in reverse order. And now the head of the queue, which is 1 here, is at the end of the array. So we can pop it off in O of 1 time, in O of 1, right? In constant time. However, the process of transferring all of the node from stack 1 to stack 2 is O of n, right? Is uh, linear time, right? So the first time is O of n, right? When we pop the one off, we have to transfer all element from stack 1 to stack 2, right? But if we want to pop off the elements, the remaining element, it will be in constant time, right? O of 1, 3 is O of 1, right? 4 is O of 1, right? 5 also O of 1, right? So it's only cost linear time for the first operation. So whenever the second stack is empty, right? So if you think about it, we have 5 elements, right, in total, right? The first one costs O of n, right? And we can divide it by n, which is because we have 5 elements here, right? Which is equal to 1, right? To O of 1. So because all of the elements after the first one, when stack 2 is empty, we were able to pop it off the queue in constant time. So the average runtime for pop would be uh, constant of 1, right? So we can do it in constant time. Okay. So yeah, so after we pop this off, right, we can add more elements, so like 6, So we delete one, right? So one is here, and now we add 6, right? So we can just add it in our stack 1, right? And we can just keep adding or removing the elements until stack 2 is empty, right? And when it is empty, then we can just like repeat the process, right? Just transfer all the elements from stack 1 back to stack 2 and do the pop again. Okay, so what about the peak here? But based on our new setup, the peak would have a different runtime, right? So the peak would always be the first element in stack 1, right? Right. But so what if stack 1 is empty? So let's say we have 5, 4, 3, 2, and 1, right? Without number 6 here. So right, remember in the previous state we had 1 to 5, right? So our peak now would be the last element in stack 2, right? So we have two cases. The first case is when the stack 1 is not empty, right? Then the peak will always be the first element in stack 1, right? But if stack 1 is empty, then the peak has to be the last element in stack 2. So that is the general algorithm. So let's go ahead and implement this. Okay, so I have set this up. We have different structure, and I'm initializing two stack, right? Stack 1 and stack 2. So when we push something into our queue, we can just simply go this dot stack 1 dot push x, right? That's it. And then pop. So if this dot stack 1 or stack 2 dot length is equal to 0, right? Which means we have to transfer all of the element from stack 1 to um, stack 2. So transfer, so move elements from stack 1 to stack 2, right? And then after that, we can just return, right? Stack 2 dot pop, right? Because after we move the element from 1 to 2, which means it will be the element will be in the opposite order, and the head of our queue will be the last element in stack 2, right? So we need to implement the helper function. So can we move? Uh, let me just copy this. And since it is a helper function, I should put an underscore here. Okay, so y stack 1 dot length. We can do stack 2 dot push and stack 1 dot pop, right? Okay. Uh, for peak, so as I said earlier, uh, we have two cases, right? The the peak the peak element will always be the last element. So let me bring back the picture here. So the peak element. So if okay, if stack 2 dot length is greater than 0, right? Then the peak will always be the last element in the stack 2, right? Peak is equal to last element in S2, right? And else. So else if S2 dot length is 0, right? Is empty, then the and then the peak will be the first element in stack one. But in that case, we can just we can either do that, or we can just move all of the element from stack one to stack two, right? And then we can always look at the last element here. So it will be either the first element in stack one, right? Or we can move all elements in stack one to stack two, right? Then look at the last element in stack two, right? So there's two ways we can do it. Okay. So if this dot stack two dot long is equal to 0, right? I can just move all of the element from stack one to stack two again. So I'm taking the second approach here, right? So after I move the element from stack one to stack two, I can just always look at the last element in stack two, right? So y minus 1, okay? And empty. So our queue will be empty when both stack are empty, right? Okay. Let's give it a try. Okay, the function is not defined. Right, maybe I need to put it up here. Okay. Not defined. Why is it not defined? Oh, oh, right. We are calling a method of a class, right? So we had to call this up. Yep, same mistake here. This, 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 and also here. Okay, accepted. And it worked. And we are doing very well with the runtime here. Thank you for watching.